Hi, everyone. Can everybody hear me okay? All right, cool. So as you introduced, my name is Kashif Imran. I'm a senior solutions architect in the computer vision team at Amazon Web Services. So I cover services like Amazon Textract and Amazon Recognition. How many of you are familiar with Amazon Textract? Anybody familiar with Textract? Okay. How many of you have to deal with documents in your business? All right, many of you. Awesome. All right. So we only have our 20-minute demo here. So I'm going to go through, kind of show you what is possible. Just kind of, talk about some of the few common use cases. And then I'll talk about, we have a much deeper dive chalk talk later today as well as tomorrow. So if this is a topic of your interest, feel free to, attend that one because I'll be showing, a lot more code. We'll be doing a lot more, deeper dive into the topic. So from the computer vision perspective, this is one of the problems that many of our customers have been asking us to help them solve, deal with documents, right? So a lot of industries, whether it's financial, healthcare, in many, many industries, customers still have to deal with documents, whether these are printed copies or scanned images, PDFs, and so on. And that's where we launched service at last reInvent called Amazon Textract. So Textract, obviously, one of the things it does is, plain OCR. So here I have this open in our AWS console. So one of the things we do is, on the left side, you see a document, which kind of looks like an employment application form. On the right side, you see Textract is able to extract that raw text and kind of show you, bag of words, if you will. So it's giving you, here are all the lines, the words, and it gives you additional information, things like bounding box and so on. That's why if I click on some of the text here, you see we're able to kind of point out where that text is on that page because it's returning you that bounding box information. So there's a lot of use applications that you can take advantage of using that bounding box. But that's not where, that's the core OCR piece. But the real strength, I think, comes in is being able to extract structured data out of these documents. So in this case, you see, because it looks like a form, a lot of times as developers, when we're building an application, what you care more about is, can you just tell me what is the first name here? Or what is the phone number here? Or what is the address here? Instead of just giving you all the raw text, we give you actually key value pairs. So if I switch to forms, you can see in this case, we detected that there is a key called full name, and it has a value Jane Doe. So if you are processing this document in your application, you don't need to just get raw OCR text and then try to figure out if there is a first name there and all the other fields. So we detect all these fields. Again, we give you the bounding box information, where all of these different fields are, what the values for these fields are, and then you can process them in your whatever downstream business application. So similar to key values or form extraction, we can do table extraction. So in this case, you see at the bottom of the document, there is our table. So in this case, we're telling you these are different rows, cells, what is the value in each cell. So again, you might have some document coming in with a bunch of values in a column where you might want to do some aggregation. You want to do some, some validation of the different values. You can easily then do that kind of stuff. Now, because you're able to extract this raw text as well as key values and table data, what are some of the key use cases that you can enable? So one of the use cases we have seen working with customers is search and discovery. So a lot of times, you have, millions and millions of documents sitting there, which are maybe images or scanned PDF documents. So how do you make them searchable? So let me switch to another quick demo. So this is where I'm going to show you basically the same features by extracting text as well as key values and tables. You can kind of enable very interesting use cases. So first one, we'll look at search and discovery. So here in this demo, I'm basically going to upload a sample document. So let me choose a sample document here from my desktop. I'll use the same employment application form that I showed you earlier and click upload. Once the document is uploaded, we go to the next screen. So in this case, you can see I actually already have a bunch of documents uploaded here. So let's see. So you can see there is already a bunch of documents that I had uploaded, and this was the one that I just uploaded. For a few seconds, you saw it was processing the document. So what it was doing is, behind the scene, uploaded the document to an S3 bucket, and I'll talk about the architecture in a second. So there is some serverless and Lambda stuff, which is calling Textract. It extracted all the stuff, all the text out, put it in an Elasticsearch cluster. So now, if I want to search, let me search for word Jane, for example. So out of all the different documents that you're seeing, now it's able to go and say, okay, there is a document which has the word Jane in it, and it's showing up there once, right? So similarly, if the Jane was there 10 times, you will see the count that this document has this Jane multiple times and so on. So simply by extracting text out of that image or a PDF, scanned PDF, you're able to basically enable discovery of those documents. Since I found that document, let me click on it. So this is the same document we saw earlier. Let me just click on Download Original. So this is the same image. Now, one of the things a lot of times end users want to do is, okay, this is an image, but how do I, we make it searchable, but maybe I want to copy and select some of that text, right, and maybe paste it in another system or something like that. So just because we were able to extract all the text as well as all the bounding box information, we can use that to generate, let's say, a searchable PDF. So if I click on this, it gives me a PDF document. And let me do Command F here. And let's say search for Jane. So now, in this case, you can see the input was image, but because we know where all the text is, now when I do Command F, it's able to highlight that text, right? So I can select that text like you expect for any traditional document, copy it, and I can paste it if I need, right? So very simply, because we are able to extract all the information needed along with where that information is, it's a very, very simple type use case which the end users expect, but can be very challenging if you don't have a service like Textract to give you all the text that you need along with the information. Let's look at another use case. A lot of times, compliance is a very common use case. A lot of times, maybe you have millions of documents sitting in an S3 bucket, and you want to make sure some of the retention policies are being applied. Maybe there is stuff that needs to be redacted. Maybe some of the documents that need to be shared within the organization, but before you share those, some part of that document needs to be redacted and so on to make sure the control and compliance is in place. So similarly, let me go to Control and Compliance. In this case, I'll use the same document, so I'll just click on View Existing and go to the next screen. I'm going to use the same document that we looked at earlier. Let me look at the key value screen. So again, similar to what AWS console showed you earlier, we extracted a bunch of those key values, and I'm showing those on the right side. So let's say I want to share this document somewhere in the organization, but I want to make sure that none of the addresses are visible as part of that document before they get shared. So I can just click here and click Redact. And again, because we know exactly where that document is, I'm quickly able to redact it. And I can say, download the redacted version. Now if I open that image, you can see that information has been redacted. So again, in this case, I kind of click this manually to show you, but a lot of times you'll probably have some automated process where you'll have tons and tons of documents coming in. You'll have some sort of business rules applied, and based on that, they will be redacting some of that information. Maybe original document will go to some store, a redacted version of the document might go to another store and a data store and so on. All right. So let's look at the third use case, workflow automation. Let me actually use the same document here just to save some time. So again, a lot of times when you extract some of this information, you usually need to integrate, text extraction, key value extraction, table extraction is the first step. And then what you need is you want to take that information and maybe bring it into some downstream system. So in this case, I'm just showing you, let's say you click on download CSV. So you can get the CSV out for these specific key values. Let's give it a second. Here's my spreadsheet. So you can see here all the key values that we extracted now available as a CSV file. So a lot of times, maybe you have a large form, you extract that stuff out, and you can easily then manipulate those files within a spreadsheet and stuff like that. Similarly, if I go to table, so let's say maybe depending on your document, the only thing you're interested is in a specific table. So I come to this table, and I say again, export this table as CSV. Click on it, and there is your table. So again, we are able to drive all of these different user experiences that I showed you, whether it was search or document redaction, or extracting all of these key values and tables and storing them in all these CSV files, because Textract is able to extract all of this unstructured and structured data, give you all the bounding box information, along with some confidence scores and so on. So those are the three kind of quick use cases I wanted to show. How some of this stuff is built. It's hard to cover all of that in a quick demo here. But here is what the reference architecture looks like. And again, if you have more time and you join one of the Chalk Talks later today or tomorrow, then we'll be spending a lot more time digging into details into this. But let me quickly walk you through on what's happening here. So in this case, as you saw, as I was uploading a document, what happens is that document ends up in this S3 bucket. And then the request goes to submit it to a queue saying, there is a document in S3, go ahead and process it. In this case, it's showing you two different pipelines. If you only are dealing with images, I mean, it kind of looks kind of overwhelming. So you don't necessarily need all of these components to build a solution that I showed you. Textract support both synchronous and asynchronous APIs. So sync APIs you can use to process like single page documents and images. So if all you have is single page documents and images, then you only need just this top piece, right? So stuff comes into the queue. Lambda can pick up that image from the queue, call Textract, get all the JSON response back, and then store it in whatever DynamoDB, Elasticsearch, or any other store that you need. If you have PDF documents or multi-page documents, maybe hundreds or thousands of pages, that's where we suggest you use asynchronous API. And the way that pattern works is, again, the request for documents comes into, let's say, an SQS. Lambda can pick up that document from the queue, call Amazon Textract and say, start the text extraction job. Or there is an API called analyze document, which says, go ahead and extract all the keys or tables that I need. In that case, Textract can then basically start that process. Whatever hundreds or thousands of pages are in the document, it can process all of those. And then once the job is done, via SNS, it can notify you that the job is complete. Once the job is complete, via SNS, it can trigger another Lambda, which can then basically go to Textract, get all the response back, and again, store all the results in DynamoDB, Elasticsearch, or depending on whatever data store you need, and so on. So with this kind of architecture, again, it's very simple to implement. In fact, this reference architecture is published. So if you look at the GitHub repo at the top, I mean, you can get it. Just run it in your AWS account and test it out yourself. I have customers who have used exact same architecture and take reference implementation with minor tweaks to process like 100 million documents within like a couple of day window that they wanted to do. And the amazing thing is, once you're done with that batch, let's say, because it's all serverless, you don't need to tear down any infrastructure, nothing, right? Everything is just Lambdas are there. Next time you have the next batch, then you can process that and so on. One thing I did not cover as part of the demo, but this repo shows, is if you have both real-time and batch use cases, the same reference architecture can help there. So I only talked about the real-time use case where stuff is coming to S3, request goes to a queue, and then Lambdas just process them. But a lot of times in the financial industry and healthcare industry, as I've talked to customers, we found out that a lot of times there are batch of documents. Hey, we have 100 million documents sitting there, we need to process that batch. Or we get a batch of 50 million every 3 months, and that's what we need to process as well. So what you can do is just use the exact same architecture with one more service. So how many of you are familiar with S3 batch operations? Anybody familiar with S3 batch operations? So S3, you can have, whatever, hundreds of millions or billions of objects in an S3 bucket. What S3 batch operation does is it allows you to trigger a Lambda function for every single object in your S3 bucket. So if you have a billion documents sitting in your S3 and you say, I want to process them with Textract, you can just go to S3 batch operations and say, trigger a Lambda for every single object in my S3. What it's going to do is basically trigger a Lambda. It means for every single document, Lambda gets called, which can then put that document in that pipeline and say, go ahead and process this. And since that pipeline is all nicely using like SQS and all that to make sure that you have highly scalable architecture, that Lambda will continue to get called for every single object, and the pipeline continue to process those, and so on. So all you have to do is, depending on the size of the batch, depending on how quickly you want to process those, you will just simply come and set the concurrency limits for all of these different Lambda functions and so on. So that's pretty much what I wanted to cover in this demo. As I said, if this is our topic of interest, we have a Chalk Talk at 7 o'clock today in ARIA. And then we have a repeat of that Chalk Talk tomorrow afternoon. So you're welcome to attend any of those two if you want to learn more about any of this topic. We have about 3 minutes left, so I'll be happy to answer any questions that you guys have. And then after that, I'll be down there for like a couple of more minutes. So happy to answer any of the questions as well. So is there a question?
Thank you. When you got documents with charts in them, not only tables or text, but charts, accesses and values, can you process these as well?
All right, so the question is, if there are charts, can you read those as well? So it depends, obviously from the OCR part, we should be able to. When it comes to the key value structure, the idea is Textract is able to read documents as like any human user would read. So if chart has a structure where maybe you have a form-like structure, then it would work. But traditional charts usually don't have key value structure. So from the OCR side, you should be able to get the OCR text, and then based on that, process that. But when it comes to table within the chart, I don't know, I'll have to see, right? I mean, you can go really fancy when it comes to these charts and graphs and so on. So it really comes down to the type of documents. Question?
Hi, do you have any strategies for like time-based redaction? So after say 5 years, you can unredact?
So the question is, do you have a strategy for like redaction, time-based? So in this case, Textract, all it's doing is extracting all the information along with like bounding box and stuff that you need. It's up to you as you implement your application, like what is the policy you want, right? So in this case, let's say you redact the document, you put it in S3, whatever, and you have an original version somewhere else. It's all that you can handle in your application. So Textract itself is not doing redaction for you. It's giving you all the text, all the key values, all the content that's there, and it's up to you how you want to apply some of those policies. Any last question? We have 2 minutes left.
Yeah, two small questions. Do you have an idea of the pricing model for Textract? And the demo you have, are they on GitHub somewhere? The demo?
Demo, got it. Are they on GitHub? Sure. So 2 questions. One is about pricing. So pricing information is on the public AWS site. We have different APIs, analyze document versus text. So there is different pricing for each one. For detect text, I believe we charge $1.50 for per 1,000 documents. The other question was the demo that I just showed, is that available? So this is going to be this demo. So this is going to be available on GitHub. I don't have the link right now, but I'll be able to share that in the Chalk Talk, if not today, maybe tomorrow. That is being published, so I should be able to share that. But as it gets available, this is going to be linked from the Textract documentation. So if you go to Textract documentation, there is a tab called examples, it should be listed from the documentation, so you should be able to find it from there. Well, thank you everyone for attending. And as I said, if you're more interested, attend the Talk and we can go deeper dive there. Thank you very much.